Yeah, hello everyone. Welcome to our course Reinforcement Learning. As part of this course, in this lecture, I will explain new environment, reinforcement learning environment, that is the gymnasium environment that is available in Python. That's called MountainCar. So we will discuss about this MountainCar first. Later, in the next lecture, we will discuss the implementation. So if you want to use the MountainCar, so you have to use this library. This you have to call like this MountainCar V0. So what it teaches? So MountainCar teaches an important idea in the reinforcement learning. MountainCar environment will teach us the important idea in the reinforcement learning. And what is that idea? The best immediate action. The best immediate action is not always the best long-term action. Whatever the action we thought it's the best at present may not be a best for a long term, right? So sometimes moving away from the goal leads the highest cumulative reward also. Sometimes every time we are working towards the goal, sometimes moving away from the goal also will give the highest reward in future. So that will explain in this environment. For example, you can see here. So this is the Hughes Valley. So this is the Hughes Valley, and here there is a car. The goal of this car is to reach this flag point, this goal. The aim of this car is to reach this goal or to reach this flag point. The car starts near the bottom of the valley. Its engine is too weak to drive directly to the goal. Suppose the engine is too weak to directly go to the goal, then what we can do? See the answer. Can the car simply press the accelerator and climb the hill? Engine power is not sufficient. So if you press on the accelerator, the car will reaches the flag or reaches the goal. Generally we thought it will, but it will be difficult, because the horsepower of that engine is not sufficient to pick up and to reach that goal, to reach that flag. Then what we can do? So instead of moving forward with this low horsepower, it's better just come back. So move away from the goal, move away from the goal. So move to the left side, move towards the left, move toward the left, move away from the goal, back, move back, and you got some momentum. When you go back, so you get some kinetic energy. So you got some momentum. With that momentum, along with your horsepower, if you press that accelerator, then you will reach this goal point. So even though if you are moving away from the goal, at this moment you feel that you are moving away from the goal, but once you are moving away from the goal, you got the required kinetic energy, and if you use the accelerator, then immediately you reach the goal fastly. You got the highest reward. You reach the goal, you reach the highest reward. That's what your MountainCar explains. So move backward, move left, and gain some momentum. Now forward by pressing the accelerator, then reach the goal, So that is the how the car can work in the valley to reach this goal point. Some other examples, like see when some boy swing, okay, you want to reach the more height, means you have, if you want to reach the more height, means he maybe go back for long and then move forward, then he can reach here. So that's how we are swinging. If you swing slowly, you can't reach the maximum peak point. If you go back, then you will reach the maximum peak point while swinging. So that's how your MountainCar works. So you can see here, maximum engine power is 5 units, but height of the hill is 10 units. So your car alone not climb the hill. Then the car take the back, take left, take back, and then press on accelerator. So with its own horsepower, along with the gained momentum, so it reaches the flag. Okay. So this is how your mountain car will work. So from here, if you observe, so who is the agent? So in a reinforcement learning, we have to discuss the few parameters like who is the agent, what are the actions, what is the state, what is the reward, what is the goal. So we have to provide the complete information about the environment to the agent. So what is the agent first? Here the agent is car. So what is the goal of what is the main aim of the agent? To reach this goal. Okay, the main aim of this agent is to reach this goal. So what is the environment? So environment is a valley. Environment is a valley. Okay. Now what are the states? So state of the agent is represented as position and velocity. In which position the car is located and what is the current velocity of the car. So the two parameters will be reflected in the state. So in the state, the position of the car and velocity of the car will be represented. The state of the car, state of the agent is represented in terms of the car position and the car velocity. These two parameters represent the state of the car. And what are the actions? The actions are either the car move left or the car move right or the car stays, no acceleration, it is a calm, it is not no movement. So left movement, right movement and no acceleration, no movement. So there are three actions. So actions are three. 0 means you accelerate left, that means this side. And 1 means no acceleration, stay calm, no movement. 2 means accelerate right, that means toward this direction. So these are the three actions are available in the mountain car environment. So action space contains the three discrete values 0, 1 and 2. 0 means left movement, left acceleration. 1 means no acceleration. 2 means acceleration towards right side. So what is the reward? So each time step you got the reward of -1. You got the reward of -1. So there is no positive reward until it reaches the goal. Until it reaches the goal, there is no positive reward. Why there is no positive reward? If you are giving the reward as a +1, every time the car moves front, moves back, moves front, moves back. So it got rewards continuously +1, +1, +1, +1. So the reward is continuously increasing, but it not reaches to the goal. So once it got a reward with a small front and back, if it got a reward, it stays calm like that only, front and back, front and back, front and back. So, but this is not a goal, right? It should reaches the goal with a less amount of time. If you take the more steps, more -1s. So you have to reach the goal at a small amount of time. Then your negative penalty will be reduced. Once you reach the goal, you got the more positive reward. Once you reach the goal, you got the more positive reward. For every movement of a car, it will give the -1. So what the goal of the agent is, reaches the goal, reaches the flag point to get the highest positive reward with less movements. With less movements means when the movements are very more, there is more -1s, -1 plus -1 plus -1 like that. If the number of steps are less, then only -1 plus -1 -2 or -1 plus -1 -3. If the movements are 100, -1 plus -1 plus -1 up to 100 to the -100, then penalty will be increased. Okay, so your goal is in such a way that your penalty will be reduced so that you complete the task with less steps and you have to reach the goal as fast as possible. Reach the flag as fast as possible. Okay, that's why we kept the -1. Why you kept the reward equal to -1 instead of the +1? If you give the +1, that your car will take the small step front, small step back, small step front, small step back. Every time it got 1 and 1 and 1 and reward continuously. Then it's not good, right? We are not giving the reward for move front and back. We have to give the reward to reach the goal. That's why for every movement without reaching the goal, we will give the penalty -1. Once it reaches the goal, we will give the high reward. So what the agent will do? Reach the goal to get the high reward. At the same time, the penalties, the number of movements should be small. If the number of movements are large, then negative penalty will be increases. So for that purpose, we are giving the reward equal to -1. So what is the goal? Reach the flag at top. Reach the flag at top. And episode ends, when the episode ends, once the car reaches the goal, once the car reaches the flag, episode stops, or maximum number of steps are reached, then your algorithm will stop. Okay, so you can see, once again I will tell this one. This is the valley. and this is my goal point, and this is the car point. If you give the reward equal to +1, what happened? This car will move front one time, so got one reward, and it will go back, and it got one reward, and front one reward, and back one reward, one front one reward, one. So without reaching the goal also, it continuously increasing the reward. That's not our. I don't want to train the model like that. So this is not the best strategy. So then instead of the +1, we will give the reward of -1. Then what happened? If it unnecessarily moving the front and back, it take the more number of steps, then what happened? Its penalty is continuously increasing. So then your algorithm in such a way that the penalty should be reduced. If the penalty should be less, means the number of steps should be less. So and reaches to the goal, so get the maximum reward. Maybe let us do, I'm saying that maximum reward is 100. So if the number of steps are -1, -1, -1, -1, and after 4 steps it reaches to the goal, then 100, then it has the reward of 96. So that your car is trained in such a way that it reaches to the goal with less number of steps. It will not take the more number of steps. Suppose if you take the 100 steps, then what happened? -1, -1, -1, like that 100, and plus reaching the goal 100. This is the -100, and this is the +100, and finally you got the 0. Then no use. So your agent, your car will learn in such a way that it reaches the goal with less number of times, so that it got the highest reward with less penalty. That's how your mountain car environment will work. So I hope you understand this one, and in the next lecture we will discuss about the Python implementation of this environment. So until then, bye. Thank you.